Hello everyone, welcoming you to Shorup's classes. So today we are looking at the DSE 2021 paper, question number 44. Suppose we run a OLS regression yi equals to alpha plus beta xi plus epsilon I, where the notations have the usual meaning. So after this we get the estimate as this, and now we regress yi on yi hat. The estimated coefficient of yi hat is gamma hat. Then which of the following is correct? So the initial one is yi equals to alpha plus beta xi plus epsilon I. This is the model, and from OLS we get this yi hat equals to alpha hat plus beta hat xi, and hopefully you remember that the expression for beta hat is basically covariance of x and y divided by variance of x. This was the expression. Now suppose you regress y on y hat. This is the thing. So something like the model will be like um, delta plus gamma yi hat plus, let's say, ui. This is the model. And after fitting OLS, you will be getting an expression for gamma hat as well. Now have a look at this. If you understand it from the previous one, what will be the estimate gamma hat? It will be basically covariance between yi and yi hat divided by your variance of yi hat, right? This is what it will be. And if you just substitute the expression that you have earlier, which is basically yi hat is alpha hat plus beta hat xi in both the numerator and denominator, then we can just have a two-step simplification over here. This is what we have. So this is basically covariance of y hat and alpha hat. So covariance y and alpha hat plus beta hat covariance y comma x divided by variance of alpha hat will be basically 0. So beta hat whole square variance of x. Covariance between y and alpha hat is 0, so this is basically 1 by beta hat times covariance of x comma y divided by variance of x. And if you look at the earlier expression, this is nothing but beta hat. So this is 1. Therefore, gamma hat is 1, which is basically matching your option number 4 in this case. Option number 4. Okay. So now moving on to question number 45 of the DSE 2021 paper. So let x1, x2, x3 be three pairwise uncorrelated random variables. That means uncorrelated random variables basically means that covariance between any two of them is 0. Covariance x1, x2 is equals to covariance x2, x3 is equals to covariance x1, x3, which is equals to 0. The mean and variance of each variable are 0 and 3 respectively. That means expectation of x1 equals to expectation of x2 equals to expectation of x3 is 0, and the variances are 3. So variance of x1 equals to variance of x2 equals to variance of x3 is equals to 3. So we need to find the correlation between x1 plus x2 and x1 plus x3. So before finding the correlation, let us first calculate the components. The covariance between x1 plus x2 comma x1 plus x3. Let's calculate that first. So if we use the property of covariance, this is variance of x1 plus covariance of x1 x3 plus covariance of x1 x2 plus covariance of x2 x2 x3. So The second, third, and the fourth terms are 0, so this is basically variance of x1, which is 3. So for calculating the correlation coefficient, we also need the expressions for variances. So what is the variance of x1 plus x2? It is variance of x1 plus variance of x2 plus 2 times covariance x1 x2. So this is 0, so this is 3 plus 3, answer is 6. And variance of x1 plus x3 is similarly variance of x1 plus variance of x3 plus 2 times covariance x1 x3. So this is 3 plus 3, 6. So what will be the correlation coefficient? It is the covariance, which is 3 divided by standard deviations of these two variates. So this is 3 by 6, which comes out to be half, which is basically your option number 2 in this case.